Okay, so for quinoline nucleophilic substitution, the way that this is going to work is we're going to draw our quinoline ring again, and then we look at the nitrogen, and we have positions relative to the nitrogen. Everything's thought of relative to the nitrogen, and so we have alpha, beta, and gamma next to the nitrogen. So alpha, beta, and gamma next to the nitrogen. And from these three positions, we can have alpha attack. So in that case, we'd have the nucleophile. So this is alpha attack. So we're gonna have the nucleophile attack at that alpha position and push the electrons over the nitrogen. And the product we're gonna get So this is the product we're gonna get. Or we can attack gamma. And for gamma attack, this would be the initial product. So now we have to compare these two. We have to think about which one is one going to be more likely? If so, which one will be more likely? So for alpha attack, the product again is going to look like this. Actually, okay, never mind. Let's do that. Okay, so basically for, sorry, I got ahead of myself here. This is true for quinoline. Now for isoquinoline, let's do the same exercise. Let's do the same exercise first. I don't want to get ahead of myself here. Okay. Okay, so that was quinoline. Now let's do isoquinoline. So again, we can have alpha attack, and in quinoline's case, we have two different alpha positions. So I'll draw that out. Okay, so this is isoquinoline. And so we've got two alpha positions that can be attacked. Remind yourself why this guy can't be attacked. Remember what would happen. Draw it out. So in this case, we have two alpha positions. And so we need to figure out. We can alpha attack at both places. So let's draw these products and figure out if A, if these can happen, B, if it can happen, which one's going to be more likely. So if it's going to alpha attack at this position at the bottom here, so we could have alpha 1 essentially. This is alpha 1. We're going to get to this product. And if a nucleophile attacked at alpha 2, that other position, we get a product that looks like this. So in this case, it's more likely to attack on alpha 1 because we left the negative charge on the more electronegative atom. The atom that's better able to handle a negative charge. In the other case, we've left it on a negative charge on carbon. So we left a carbanion hanging out. So it's more likely that we're going to attack over at alpha 1 there, the top one, for isoquinoline. For quinoline, both of these are possible. Both the alpha and the gamma attack are possible. For isoquinoline, it's more likely to attack at that alpha 1 position. And remember now, inductively, those positions are electron poor. You can look back and look at how that works on the carbon NMR. You can check with the carbon NMR about that.